You're probably sitting somewhere right now, maybe scrolling on your phone or watching this on a screen, and everything around you feels stable. The ground feels solid, the air feels calm, and the moment you're in feels like it belongs to you. If someone asked you to point to now, you'd probably snap your fingers and say, right here. It feels obvious. It feels natural. But here's the uncomfortable truth. Our instincts about how the world works are often wrong. They evolved to help us survive on the savannah, not to understand the universe. The same instinct that tells you to run when it starts raining is built on simple logic. Spend less time in the rain, get less wet. It sounds flawless. Yet nature loves to trick us with simple problems that hide deep truths underneath. So today we're not just talking about rain. We're talking about geometry, motion, and the hidden rules that govern how we move through the world. When rain starts falling, your brain immediately frames the problem in terms of time. The longer you stay exposed, the wetter you become. It's like marbles dropping from the sky into a bucket on your head. Stand still long enough, and that bucket fills. Run, and you shorten the exposure. But here's the thing your brain forgets. You are not just a point in space. You are a moving three-dimensional object with a front, a back, a surface area. When you stand still, rain hits mostly the top of you. When you move, you don't just change time. You change how you collide with the rain itself. Imagine walking through a hallway filled with floating beads. They're suspended in the air, perfectly still. No matter how fast you move, you must push through the same volume of space to reach the end. Whether you sprint or stroll, your body intersects the same number of beads. Speed changes how quickly you hit them, not how many you hit. That's the key idea. The rain in front of you is already there, waiting like a wall. When you run, you smash into that wall faster. When you walk, you meet it slowly. Either way, the total amount you encounter from the front doesn't change. Suddenly, the problem isn't about escaping the rain. It's about choosing how you collide with it. This is exactly how physics approaches motion. Instead of thinking in terms of feelings, it breaks problems into components. Newton taught us to think in vectors, little arrows describing motion. Rain falls with a downward arrow. When you run forward, from your perspective, the rain appears angled, coming toward your face. The faster you move, the more horizontal it seems. It's the same effect you notice driving in a storm when droplets streak across the windshield, rather than landing softly on the roof. Motion reshapes your reality. And once you see that, you realize the universe doesn't care what feels logical. It only cares about how objects interact in space and time. So classical physics gives us a simple conclusion. The rain hitting your chest depends on distance, not speed. You must travel the same distance to reach shelter, so that exposure is fixed. The rain hitting your head depends on time, and time shrinks when you move faster. Therefore, if we only consider these two effects, the answer seems clear. Run as fast as you can. Minimize the time cost because the distance cost is unavoidable. But the story doesn't end there. Because the moment you try to apply this idea to the messy real world, cracks begin to appear. Because reality is never as clean as the diagrams we draw. In textbooks, rain falls perfectly vertical, and bodies are treated as simple shapes. But in the real world, droplets splash, wind tilts their paths, and your body isn't a smooth geometric block. Still, even in the idealized world of physics, something deeper is hiding beneath this simple rain problem. To uncover it, we have to stop thinking about drops of water and start thinking about something physicists call flux, the flow of particles through a surface. Whenever scientists study collisions, whether it's raindrops hitting your jacket or electrons smashing into atoms, they talk about cross-section. Imagine yourself as a target in a stream of tiny projectiles. The cross-section is basically how much of you is exposed to that stream. When you stand still in rain, your cross-section to vertical drops is just the top of your head and shoulders. It's small, but when you move forward, you effectively tilt your exposure. Suddenly, your entire front becomes a target. You've transformed from a small lid catching rain to a moving shield plowing through it. Now imagine slicing space itself into thin layers. In each layer, raindrops exist with a certain density, say 1 drop per cubic inch. As you move, you sweep out a volume of space. That volume is determined purely by your surface area, multiplied by the distance you travel. Notice something important. Speed isn't in that formula. Time isn't either. Geometry alone determines how many drops lie in your path. This means the amount of rain waiting in front of you is fixed the moment you decide where you're going. Running doesn't remove it. It only changes how fast you encounter it. At this point, it feels like we've reached a dead end. Horizontal exposure is fixed. Vertical exposure shrinks with speed. So mathematically, shouldn't you just run infinitely fast and minimize total wetness? In a perfect world, yes. But now physics asks a deeper question. What happens in extreme limits? Imagine running unbelievably fast, so fast the rain seems frozen in place ahead of you. In that case, you'd hit every droplet in your path almost instantly. But there's another trick hidden here. Orientation. Watch how people run. They lean forward. That lean subtly changes their cross-section. By tilting your body, you reduce the area directly facing the rain. If you could lean perfectly horizontal, like Superman flying through the storm, you'd slice through the droplets with minimal exposure. Suddenly, the problem shifts again. It's not just about speed. It's about geometry, about how you position yourself relative to the field you move through. This idea isn't limited to rain. It's fundamental to how particles interact with light, with fields, with each other. In electromagnetism, the strength of interaction depends on the angle of incidence. In quantum physics, scattering probabilities depend on orientation and cross-section. What feels like a trivial choice, how you run through rain, is actually a miniature version of how matter interacts with the universe. But to see just how deep this goes, we have to stop thinking only about space. Because rain doesn't just fall in space. It falls in time. And once you bring time into the picture, the problem stops being about getting wet and starts being about how you move through reality itself. Physicists rarely talk about space and time as separate things anymore. Instead, they talk about space-time, a single four-dimensional fabric where motion is simply a path through that fabric. Imagine space-time as a giant loaf of bread. Each slice represents the universe at one instant. When you stand still, your path through space-time is like a straight vertical line passing through slice after slice. But the moment you move, that path tilts. You begin slicing the loaf at an angle. Your personal now shifts depending on how you travel. Let's translate that idea back into the rainstorm. Picture a graph where the vertical axis is time and the horizontal axis is space. A raindrop sitting on the ground traces a vertical line upward as time passes. A falling raindrop traces a slanted line, moving through space as it falls. And you, standing still, trace your own vertical line. When you run, your line tilts. The amount of rain you encounter becomes the number of points where your path intersects the raindrop's paths. Wetness isn't just about water anymore, it's about intersections in space-time. This way of thinking reveals something strange. We normally assume the rain exists independently of us, that it's simply there waiting. But in physics, especially in quantum theory, events only become real when interactions occur. A raindrop hitting your coat is an event. Without that collision, it's just a probability drifting through the universe. By choosing to run or walk, you're actually deciding which events will happen. You're choosing which droplets become part of your history. That sounds philosophical, but it's grounded in real science. At the atomic level, both you and the rain are mostly empty space. Atoms are tiny nuclei surrounded by clouds of electrons separated by vast gaps. When rain hits you, it's not solid matter slamming into solid matter. It's electric fields repelling other electric fields. The droplets don't truly touch you. They're stopped by forces between charged particles. Your wetness is the result of countless microscopic interactions, tiny force field encounters shaping your macroscopic experience. Now, zoom out even further. If motion changes how you encounter rain, could extreme motion change how you encounter time itself? According to Einstein's relativity, the answer is yes. As you approach the speed of light, time for you slows relative to the outside world. From your perspective, the distance ahead contracts. In the absurd limit where you move at light speed, the journey shrinks to zero distance and zero time. You'd reach the shelter instantly, encountering all the horizontal rain at once while experiencing no vertical fall at all. Of course, you can't actually do that. You have mass, and mass resists acceleration. Reaching light speed would require infinite energy, so you remain stuck in the middle ground, moving through space-time at ordinary speeds, feeling both the downward drip and the forward impact. And that's where physics leaves us, with an answer that is both simple and profound. Yes, mathematically, running reduces the time you're exposed to vertical rain, but the horizontal wall remains unavoidable. The universe doesn't let you skip encounters. It only lets you choose how to meet them. Yet, even that conclusion misses something important, because we've forgotten one chaotic player in the system: the ground. While we were busy analyzing rain from above and ahead, we ignored what happens beneath our feet. In real storms, streets fill with puddles. Surfaces become slippery. Every step sends tiny splashes upward. When you run, you don't just collide with rain, you create new water motion yourself. Your shoes become paddles, throwing arcs of droplets onto your legs. The faster you run, the more chaos you generate. This is the part textbooks often forget. Physics models start simple. They isolate variables, strip away complications, and reveal elegant truths. But real life is always messier. Models assume smooth surfaces, ideal flows, perfectly shaped bodies. Reality gives us potholes, wind gusts, uneven terrain. So the real solution isn't just about optimizing speed. It's about balancing theory with practical limits. That leads to a beautifully simple rule. Run, but not recklessly. Move fast enough to shorten exposure from above, but not so fast that you lose control and crash into the ground. Because the moment you slip into a puddle, all the careful geometry collapses. Instead of partial exposure, you're completely soaked. In that instant, optimization becomes irrelevant. You've lost the game. And that tiny lesson mirrors a much larger truth about life. We spend enormous effort trying to optimize our paths, working faster, pushing harder, racing toward goals. We think if we just minimize delays, we can avoid discomfort. But there's always a horizontal wall waiting. Work to do, obstacles to face, experiences to live through. You can compress them into shorter bursts, but you can't remove them entirely. Geometry and conservation laws won't allow it. So running through rain becomes more than a trivial puzzle. It becomes a metaphor for how we navigate existence. We can't escape the volume of space we must occupy, the challenges we must encounter. All we can do is choose our orientation, how we face them, how we move through them, how we balance speed against stability. And perhaps that's the most empowering part. Even in a situation where the outcome seems fixed, you will get wet, you still have agency. You can choose your cross-section. You can choose how you slice through space-time. That choice, small as it seems, is the difference between chaos and control, between panic and understanding. Which brings us to the final piece of the story. Because at its heart, physics isn't about avoiding problems. It's about understanding them. When you understand why rain hits you, why motion changes perception, why forces shape interactions, the world stops feeling random. It becomes a system. Complex, yes, but governed by rules you can learn. The rainstorm isn't your enemy. It's a demonstration of how geometry and motion work together. This perspective changes everything. Instead of seeing yourself as a victim of the weather, you see yourself as part of the system. Your movement alters the interactions around you. Your decisions shape which events occur. You're not separate from the universe. You're a participant in it, constantly exchanging energy and momentum with everything you encounter. And once you start seeing life this way, small experiences feel larger. Walking through rain becomes a lesson in relativity. Watching droplets streak past a window becomes a demonstration of reference frames. Even the simple act of leaning forward while running becomes a reminder that orientation changes interaction everywhere, from raindrops to photons. Understanding doesn't remove inconvenience. You still get wet, but it replaces confusion with clarity. And clarity brings a strange kind of satisfaction. Knowing why something happens can feel just as rewarding as avoiding it altogether. So, The next time you're caught in a storm and feel that instinct to sprint for cover, go ahead and run. Feel the wind on your face, the droplets striking your jacket, the rhythm of your feet hitting the ground. But remember what's really happening. You're not escaping the rain, you're negotiating with it. You're choosing how your path intersects with the world's motion. You're choosing your slice of space-time. That's the beauty of physics. It doesn't strip wonder from the world. It adds layers to it. The rain becomes more than water. It becomes geometry, motion, interaction, probability. And you become more than a person trying to stay dry. You become a traveler through a universe governed by elegant rules. We can't always control what happens to us. Storms come, obstacles appear. But we can control how we move through them. We can choose our speed, our angle, our balance. And sometimes, understanding those choices is more valuable than the outcome itself. Because the universe is, at its core, just a vast collection of things bumping into other things, following a handful of beautiful, strange laws. And every time you step into the rain, you're part of that grand experiment. So the next time you're caught in a storm and that instinct kicks in, that voice telling you to sprint for shelter, go ahead and run. Feel the wind push against you. Feel the droplets hitting your jacket and your face. But understand what's really happening. You are not escaping the rain. You are negotiating with it. You are choosing how your path through space and time intersects with everything around you. You are choosing your angle, your speed, your slice of the universe. That's the real beauty of physics. It doesn't take wonder away from the world. It gives it structure. The rain is no longer just water falling from the sky. It becomes motion, geometry, interaction, probability. And you are no longer just someone trying to stay dry. You are an object moving through a field of events, shaping which ones become real simply by how you move. We spend so much of life trying to avoid discomfort. We rush to beat traffic, to meet deadlines, to outrun inconvenience. But the universe rarely lets us avoid the encounter entirely. What it does allow is choice. Choice in how we face the encounter, how we move through it, how we balance speed against stability. You can't eliminate the rain. You can only decide how you meet it. And that's a powerful thought. Even in situations where the outcome seems fixed, you still have agency. You still shape the experience, the geometry of your path, the angle of your movement, the decisions you make. They all matter. You are not just drifting through the universe. You are interacting with it constantly, shaping your own story one step at a time. Physics teaches us that the world isn't random chaos. It's a system, a vast, beautiful system where everything follows rules, even the simple act of walking through a storm. And when you begin to see those rules, the world stops feeling ordinary. It becomes layered with meaning. Every splash, every movement, every collision is part of something bigger. So, don't worry too much about getting wet. Instead, appreciate the moment. Appreciate the fact that you can think about it, understand it, and even enjoy the puzzle of it. Because in the end, the universe is just a huge collection of things bumping into other things, guided by a handful of elegant laws. And you, right now, are one of those things, moving through it. So keep asking questions, keep noticing the details, keep exploring the strange, beautiful logic hidden in everyday life. Even if you end up soaked, at least you'll understand why.